The objective of today class is nothing but the problems on induced EMF. Problems on induced EMF. The first problem: a coil having resistance of 100 ohm is kept in a magnetic field of 1 milliweber. The coil has 100 turns. Find the average EMF and current in coil. If it is move in 1/10 second from the given field to field strength of 0.2 milliweber. From this problem, what are the given data? You have to observe. Let us know. You know that the induced EMF formula, that is the E is equal to minus N into d pi by dt, or E equal to N into d pi by dt. So here we have to find the value of induced EMF and current. So first we have to find the value of induced EMF, E equal to N into d pi by dt. So here the resistance value is given and the initial flux and final flux also given. So here the initial flux is equal to, that the flux pi 1 is equal to 1 milliweber. So here the resistance of the coil is nothing but 100 ohms and flux pi 1 is equal to 1 into 10 to the power of minus 3 milliweber, and N is equal to 100 turns, and flux pi 2 is given, pi 2 is equal to 0.2 into 10 to the power of minus 3 milliweber, weber. So from this given data we have to find the value of change in flux. So from initial flux to final flux. So that is the final flux to initial flux. Here the change in the flux equal to, that the d pi is equal to pi 2 minus pi 1, pi 2 minus pi 1. So here the pi 2 value equal to pi 1 is equal to 1 into 10 to the power of minus 3 Weber, and pi 2 is equal to 0.2 into 10 to the power of minus 3 Weber. So from this equation the change in flux, so which is equal to 1 into 10 to the power of minus 3 minus 0.2 into 10 to the power of minus 3. Then the change in flux is equal to change in flux. So that the pi 2 minus pi 1 or pi 1 minus pi 2, So here the flux is changes from the pi 1 initial flux. So with some time period, that the initially flux will be linkages or flux will be changes from the pi 1 to pi 2. So here we will take in the initial flux is the 1 into 10 to the power of minus 3 and final flux is the 0.2 to the power of minus 3. So which is equal to change in flux pi 2 minus pi 1 is equal to 0.8 into 24 or minus 3 milliweber Weber, and we know the value of the induced EMF, the E equal to N into d pi by dt. So here N is the number of turns, number of coil, number of conductors, okay, what or maybe. So here the N is equal to number of turns, number of coils. So 100 into change in flux equal to 0.8 into 24 of minus 3 Weber by the change in time period is equal to 1 by 10th time period. So then we will get the induced EMF value E is equal to 0.8 volts, 0.8 volts. So this is the by the changing of flux in a 100 tons of coil, that coil having the resistance of 100 ohms, then then the to produce the induced EMF equal to 0.8 volts, 0.8 volts. So here the induced current I is equal to E by R, I is equal to E by R. So here E equal to 0.8 by R equal to 100 ohms, R is equal to 100 ohms. So the induced current is equal to equal to 8 milliampere, 8 milliampere. Then we will get the induced voltage and the current. We will get induced voltage and the current. So this is our first problem. Next problem. A coil of 100 tons, of wire is wound on a magnetic circuit of reluctance is 1000 tons, 1000 ampere tons per Weber. If a current of 1 ampere, the flowing in the coil is reversed in 10 milliseconds. Find the average induced EMF in the coil. Find the average induced EMF in the coil. So this is our problem. Our problem. A number of turns means the conductors, number of turns, number of conductors or number of coil is 100 tons of wire is wound on the magnetic circuits, of reluctance, okay, of reluctance of that 100 tons of coil, reluctance equal to 1000 ampere tons per Weber. If a current 1 ampere flowing in a coil, okay na, so here the current flowing through the conductor or coil is the 1 ampere. It is the reversed in 5 milliseconds, Find the average induced EMF in a coil. That is we have to find the value of induced EMF. E equal to so we know the formula for the E is equal to N into d pi by dt. So here the current is equal to 1 ampere and number of turns is equal to 100. Number of turns equal to 100 is given, and reluctance is which is equal to reluctance. So reluctance is 1000 ampere tons. So here we have to find the value of n equal to 100, into change in flux. Find the value of change in flux. How to find the value of change in flux? Change in flux pi 2 minus pi 1, okay now, pi 2 minus pi 1, or same flux will be reversed in 1 second, current will be reversed in 1 second, so the same flux will be produced, that is the minus of minus pi 2. So here the reluctance value S equal to 1000 tons is given, and here so 1000 tons, so we have to find the value of MMF. Equal to number of turns into current, number of turns into current. Number of turns is given here. Number of turns how much? 100 turns, and current is the 1 ampere. So it's a mmf equal to, mmf is equal to 100 ampere turns, 100 ampere turns. Okay now. So here how much flux will be produced in that coil? How much flux will be produced in that coil? So the flux in the produced in the coil, pi is equal to mmf by reluctance, mmf by reluctance. So the mmf is 100 and the reluctance is 1000. So here the 0.1 is Weber, that is the flux, that is the change in flux, that is the flux, that is the flux. So here the flux will be reversed in how much second? 5 milliseconds. 5 milliseconds the flux will be reversed. Then the E is equal to 100 into the change in flux. Change in flux means here 0.1 minus of minus plus 0.1 by 0.5, sorry, 5 into 24 of minus 3 second. Then we will get the E is equal to 4 volts. E is equal to 4 volts. E is equal to 4 volts. That is the final voltage. That is the final voltage. That is the final induced EMF in a coil. 1000 coil having the reluctance of 1000 turns, and the current flowing through the coil is 1 milliampere. Then so the current will be reversed in 0.1 second and in 5 milliseconds. In 5 milliseconds the current will be reversed. Then the average induced EMF in a coil is equal to, class is equal to E is equal to 4 volts. E is equal to 4 volts. So this is the second problem. Next, third problem. Next problem. A magnetic flux of 10 milliweber linking with a coil of 240 turns is reversed in 0.1 second. Find the average value of induced EMF in a coil. Induced EMF in a coil. So number of coils or number of conductors is given. That is the number of turns is 240, and magnetic flux linkages with the coil is the 10 milliwebers, and time taken for the flux will be reversed. That is the 0.1 second. 0.1 second. So the change in flux equal to pi 2 minus pi 1. We know the value of the induced EMF. We know the formula for the induced EMF produced in a coil. That is the E is equal to N into d pi by dt. d pi by dt. d pi by dt. So here the N is the 240 volts. So the change in flux, that is the change in flux is equal to 10 milliamperes, 10 milliwebers, 10 milliwebers. So here it will be reversal. So here the 2 into pi 2, 2 into pi 2. So 2 into pi 2 means, sorry, pi 2 minus of minus pi 2. So that is the 2 pi 2. So 2 pi 2. So 2 pi 2. So 2 pi 2 means pi 2 value is nothing but 10 milliwebers. 10 milliwebers. So 2 into 10 milliwebers. So the induced EMF. So N into change in flux by change in time period. 240 into 20 into 10 to the 4 minus 3 by 0.1 second. Then we have to, then the final value for induced EMF produced in a, final induced EMF produced in a coil or turns. 48 volts, 48 volts, 48 volts. Next problem. A coil of 200 tons is linked by a flux of 0.65 milliweber. If the flux is reversed in 0.012 second, find the induced EMF in the coil. Find the induced EMF in the coil. Same problem. So here also is given the number of conductors and number of coils is there. The number of conductors and number of coils is the 200. And the linking, the flux will be linking is the flux linkages in the coil is equal to 0.65 milliweber is given, and if the flux is reversed in 0.012 second, that is the time period. So this is the time period. So find the induced EMF in the coil. Find the induced EMF in the coil. Here the flux will be changed. Same flux will be flux linkages in the coil is the same. That is the changing from pi 1 to pi 2, pi 1 to pi 2. So here the flux linkages in the coil is equal to 0.65 milliweber. So here number of coils or number of turns equal to 200 turns. So the changing flux equal to pi 1 minus pi 2, pi 1 minus pi 2. So here the pi 1 value equal to 0.65 into 10 to the power of minus 3 minus of minus 0.65 into 10 to the power of minus 3. So finally we will get 1.3 into 10 to the power of minus 3 Weber, milliweber. So here the induced EMF in the coil, the EMF is produced in the coil E is equal to N into changing flux to changing time, changing flux to changing time. So the changing flux equal to 1.3 into 10 to the power of minus 3. Changing time is equal to 0.012. So number of coils is equal to N equal to 200 tons. So the induced EMF produced in a coil is equal to 21.67 volts. 21.67 volts. So this is the problems on induced EMF. Problems on induced EMF. So we have to discuss today topic the problems on induced EMF. So the induced EMF is equal to the changing flux linkages. The induced EMF formula is equal to changing flux linkages with changing time. So N into d pi to d pi by dt volts. Some equation is there. Some equation we have to remember. The equation for the induced EMF is given by, the equation of induced EMF is given by option A equal to E is equal to minus of N into d pi by dt. केर पापा है हमार का A is equal to E equal to minus N into d pi by dt. E is equal to minus of N into d pi by dt, and option B is equal to E equal to d pi by dt. Option C is equal to none of the above. So option A is the correct answer. Option A is the correct answer. The equation for in the induced EMF is given by the E equal to minus of N into d pi by dt, d pi by dt, d pi by dt. So option A is the correct answer. The E is equal to minus of N into d pi by dt. Some assessment problem is there. Here a coil has 360 turns, is linking by a flux of 100 micro Weber. If the flux is reversed in 0.01 second, if the flux is reversed in 0.01 second, find the EMF induced in the coil. Find the EMF induced in the coil. So by the using of formula, induced EMF formula is so induced EMF formula E is equal to N into change in flux by change in time. So N equal to 360, the change in flux equal to 100 micro Weber, and change in time is equal to 0.01 second. Then we will get the induced EMF in a coil. Directly we have to substitute the value of in equation of E equal to minus N into d pi by dt. E equal to minus of N into d pi by dt. Then we will get 7.2 volts. 7.2 volts. We have to practice them. A DC motor. This is another problem. A DC motor, the field pole is wound with 400 turns and which carries 25 milliweber. When excited, the exciting current is then switched off and the flux is reduced to 6 milliweber in 0.03 second. Calculate the average induced EMF in the coil. Here also a DC motor field poles. On the field poles, the number of conductor is wounded. That is the 400 turns. 400 turns are wounded on DC poles, and carries the 25 milliweber is excited. So that is the excited induced EMF. So here the exciting current is the switched off. The flux will be reduced to 6 milliweber. Okay, now initially the flux will be excited at 25 milliweber here, and the current will be switched off after some time. So that is then the flux will be reduced to 6 milliwebers. Okay, now in 0.03 second, calculate the average induced EMF. Okay, now so here the change in flux is given, that is the 25 to 6 25 milliweber to 6 milliwebers in the change in time period 0.03 second. Change in time period 0.03 second. Calculate the average induced EMF in the coil. Calculate the average induced EMF in the coil. So that is the E equal to minus of N into d pi by dt. N into d pi by dt equal to 325.33 volts. 325.33 volts. So this is the average induced EMF. This is the average induced EMF. Next problem. A coil of resistance is 155 ohms is placed in a magnetic field of 4 milliweber. A coil of resistance, that the 155 ohms resistance is there, which coil are placed in magnetic field. Here the magnetic field has the flux linkages is nothing but 0. milliweber. The coil has 150 turns and the galvanometer of 500 ohms resistance is connected in series with it. Find the average EMF and the current is connected in the series with it. Find the average induced EMF and if the current, if the coil is moved in 0.15 second, 0.15 second. So here also a coil having the resistance of 155 ohms. Okay now, so this coil have to place it in the magnetic field. Okay now, here the magnetic field has number of magnetic lines of force or number of flux having 4 milliwebers, and the another coil has 150 turns, which is also 150 turns, and the galvanometer of 500 ohms resistance is connected in series with it. Find the induced EMF, current and series, and find the average EMF in the and the current if the coil is moved in 0.15 second. So this is also just here the galvanometer having the resistance of some resistance is series with it. Okay, now then we will get the induced EMF. The E is equal to minus of N into change in flux by change in time. Change in flux by change in time. Next problem, the same problem is there. Okay now, so third problem and fourth problem is the same. So this is the today class we have to discuss now. So this is the problems on Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. That is the Faraday's second law. That is the what are the magnitude of induced EMF produced in a conductors. If conductor carry electric current or conductor are placed in the magnetic field. Okay, whatever may be. But what are the magnitude of induced EMF produced in that conductor or coil? That is equal to E equal to minus N into d pi by dt, where N is the number of turns and d pi is the change in flux and dt is the time period. So based on this equation, based on the Faraday's laws of electromagnetic induction, Faraday's second law of electromagnetic induction, we have to practice the problems on it. So here the more example problem is given. We have to practice it. And some example problem is there, and the objective question also is there. So these problems and objective questions more useful to you for the diploma level or BTech level also, and for the competitive exam also. So these are the problem. Let us observe this one. We have to observe these problems. So this is the induced EMF equation. E equal to N into d pi by dt volts.